Okay, so before we begin today, I want to give everybody a heads up that we do have an exam on Friday. Um, it's going to be the third 6 weeks test, and the reason why we're going to give it on Friday is because when you guys get back soon after that, you're going to have your semester test. So we're going to go ahead and give the third 6 weeks test this Friday. Now, the third 6 weeks test will cover 3 topics. It will cover universal gravitation, energy, and working power. Okay, we're going to talk about working power on next class period. Um, I think it's somewhere around 15 multiple choice questions, somewhere around there. So it's not going to be too bad. Um, so today we're going to finish concepts in energy. Excuse me. Today we're going to finish concepts in energy, and also guys, stay on after the call if you have any questions for me. Um, Now, I'm not sure if we're going to have a live class on next class period because they want me to administer some more EOC star test this week. She didn't. She told me she wasn't going to need me the entire week, but she did tell me that at least a few days this week she would need me. So I don't know when those days are. So there's a possibility we may not have a live Zoom session next class period. I might just post a video for you guys to watch. If that's the case, just be checking into Schoology because I want to be posting updates daily in Schoology, and I'll let you guys know if we're going to have a live Zoom session next class period or not. Again, it depends on if they're going to be having me testing. So just be aware of that and be looking out for that. And remember, there is a test on Friday. Okay. Also, um, um, I'm going to have at least 2 days this week where I'm going to do some after school hours um, tutorial sessions in case anybody have any questions. I'm going to be on. It's going to probably be from like 3:20 to 4. Um, and so just keep that in mind, guys. It's going to be Tuesday and Thursday this week where I'm going to be doing some tutorial sessions from 3:20 to 4 in case any of you guys have any questions for me before you guys take the test. Uh, Michaela, the STAR test is mainly makeup ELCs. For those people who have to make up the exam, or those people who didn't get credit for their class last year. Because, like, for example, there was some students who didn't do their project and they didn't get credit for the class, so they have to take the STAR ELC. Because the STAR test was only waived if a student passed the class. So if you hadn't heard anything about taking a STAR test, Michaela, then it doesn't apply to you. Are you well, Michaela, is your question referring to the STAR testing happening right now or the STAR testing happening in the spring?
The one we have to take in order to pass.
In the spring? I don't know what they're going to do as of yet in the spring. I'm not sure, but I know the STAR testing that's going on this year is for students who didn't get credit for their class on last year. Because they waived the STAR test last year if you got credit for the class, but if you didn't get credit. And plus, there are also some students who have to take some other makeup ELCs for whatever reason. As far as what's going on in the spring, I don't know as of yet, but I'll keep you informed as I find out. Okay, let me go ahead and share my screen. So on today, we're going to be talking about conservation of energy. So just click on the Monday, Tuesday folder for today. Okay. So there's a conservation of energy PowerPoint that is posted in Schoology. And as soon as we get done going over this PowerPoint, and as soon as I go through several of the practice problems with you all, I'm going to make this assignment available to you all so that you guys can get started on it and complete it. The assignment is really only just 5 questions, but it will involve some calculations. So hopefully you guys have a calculator next to you, or you have access to the Google calculator. Okay, so before we go over this PowerPoint here, I just want to be sure everybody remember what we talked about last time. Okay. So if you guys remember last time, I introduced two main forms of energy. I talked about potential energy and I talked about kinetic energy. Okay. Now, specifically here, in this particular example here, we are dealing with gravitational potential energy. And remember what gravitational potential energy is? Is stored energy that an object has as a result of its height above the Earth's surface. So because this guy is up high on the skateboard, he currently has gravitational potential energy. And why do we call it potential energy? Because notice, if the guy's released from rest, his potential energy becomes kinetic energy. He starts sliding downward. The potential energy at the top becomes kinetic energy at the bottom. Um, and that's because all of that stored energy had the potential to become another form of energy, in this case, kinetic energy. And what is kinetic energy, guys? Remember, kinetic energy is the energy of motion. Okay, kinetic energy is the energy of motion. Okay, so basically, the faster an object goes, the greater the kinetic energy it has. Okay. In the case of gravitational potential energy, the higher an object is, the greater the potential energy it has. Okay. So again, this was just something we talked about last time. Okay. Today on the PowerPoint, we are going to be talking about conservation of energy. Okay. Now, guys, the law of conservation of energy states that energy is neither created nor destroyed, just transformed into other forms. Okay, guys, the term conservation here, that term just means to stay the same. So when I say that the total amount of energy in the universe is conserved, basically what I mean is that the total energy stays the same or stays constant. So, guys, energy can never be created nor destroyed. It can only change forms. That's what the law of conservation energy says. So basically, what I'm saying is that the total energy content in the entire universe does not change. Okay, the total energy, it can change forms, right? Potential energy can become kinetic energy. Kinetic energy can become thermal energy. So you may change to other forms of energy, but the basic idea is that the total energy stays the same. That's behind the law of conservation of energy. Okay. Um, Positive work and negative work. That's something we're going to talk more about on next class period. Okay, but let me keep going. So, okay. Now, by the way, guys, in this particular example right here, I want you guys to keep in mind what's going on here. In this particular example right here, we say that this guy here on the skateboard, this guy makes up our system. Okay, I'm going to call him a system. So, guys, the total energy of this system will stay constant. Okay. Now, in this case, when I'm talking about the total energy of this system, here I'm specifically referring to the system's kinetic energy and potential energy. Now, I'm going to give you guys one caveat here. The total energy of the system stays constant if we are ignoring external forces. In other words, we're ignoring friction. So, guys, pretend this ramp here is completely frictionless. If it's completely frictionless, the total energy is going to stay constant. And guys, you can easily see what will happen if we add friction to this ramp, because if there was friction on this ramp, eventually this guy will slow down and come to a stop. So friction takes energy out of this system. But as long as we're ignoring external forces such as friction, we can guarantee that the total energy of the system will stay constant. And when I start talking about the total energy of the system, I'm talking about the system's kinetic energy and the system's potential energy. Okay. So guys, whenever we're ignoring friction, I want you guys to understand the basic idea here. Notice that, and this is the most important thing whenever you guys are doing your assignment. Notice that whatever the object's potential energy at the top here is equal to the object's kinetic energy at the bottom here. So at its highest point, the object has full potential energy. and then at its lowest point, okay, it has full kinetic energy. Okay, and so and guys, this system will keep oscillating like this forever and ever and ever. The total energy is just going to stay constant until we decide to take that kinetic energy and that potential energy out of the system by using external force such as friction. Okay, here guys, whenever we're at the halfway point, let me. So whenever we're at the halfway point, notice here that the energy is half and half. So halfway here, we have half potential energy, half kinetic energy. Okay. Uh, Now, one more thing I want to say about the conservation of energy before we do these math problems. Um, Guys, even though we can take energy out of this system here, the point is that I want you guys to know is that while energy can come out of a system, you can never take energy out of the entire universe. Okay, so for example, suppose that we did have friction acting on this ramp. Okay, so if we have friction acting on this ramp here, and friction slowly brought this guy to a stop. So even though friction is taking energy out of the system, right? So it's removing kinetic energy, from this guy, and he comes to a stop. That energy becomes something else. In fact, friction will turn that energy into thermal energy, right? So it's kind of like if you rub your hands. If you take your hands and you rub them together, because there's a lot of friction there, your hands will become hot. If you take your hands and you rub it together, friction creates thermal energy. So the point that I want you guys to understand here, that even though we remove energy from the guy here, that energy can go somewhere else. So it turns into thermal energy in the ramp because of friction. So the key idea is that the total energy of the universe is never lost. We can take energy out of individual systems, and we can put energy into individual systems, but we can never take energy out of the entire universe. Energy just transforms from different types. Okay, but the basic point here, guys, if we are ignoring friction, this cycle just keeps repeating itself over and over and over again. Potential energy becomes kinetic energy, back to potential energy, back to kinetic energy, and so forth. Okay, so hopefully that makes sense. Let me go back to the PowerPoint. So again, the total energy of our system before anything started acting on it is equal to the total energy of the system after anything acts on it. Well, I'm sorry. This is talking about the total energy of the system in the entire universe. Okay, guys. I wanna end the day just working on several examples with you guys. Okay, we're gonna work on some examples together so that whenever you guys are working on the assignment, you guys will know what you're doing. Okay, so this problem right here says a 40-kilogram object falls freely for a distance of 15 meters near the Earth's surface. What is the kinetic energy of the object the moment just before it strikes the surface of the Earth? Okay, so guys, for this assignment here, there's one basic thing I need you guys to know. That in all of these cases right here, since we are ignoring friction, the potential energy at the top will always be equal to the kinetic energy at the bottom. Okay, we're going to say the total of the two stays constant. Potential energy combined with kinetic energy stays constant. So I'm going to write that down because that's important that you guys know that for this assignment here. That that the object's potential energy at the top of its path is equal to the object's kinetic energy at the bottom of its path. So guys, you're going to use this relationship right here for every problem that I give you guys all today. Okay. So we said, we have a 40 kilogram object and it falls freely from a distance of 15 meters near the Earth's surface. What is the kinetic energy of the object just before it strikes the Earth's surface? Okay, so guys, if we want to know the kinetic energy at the bottom here, what we need to do, we need to find the potential energy of the object at the top. Well, guys, remember the equation for potential energy? I gave it to you guys last time. It's sometimes you'll see the equation run like this: mass times little g times the object's height. And guys, remember what little g is. Little g is always the acceleration of gravity, which is 9.8 meters per second squared. Okay, so if the object is 40 kilograms, so it's 40 kilograms, so we'll plug it in for the mass, times 9.8, and it starts from a height of 15 meters. Okay. So guys, if you put that in your calculator, and if you do the math, 40 times 9.8 times 15, here's what you get. You get 5,880 joules of potential energy at the top. Okay. But guys, notice what the problem asks for. It asks for what is the kinetic energy of the object just before it strikes the surface of the Earth. Well, guys, remember, because the total energy of the system stays conserved here, whatever the potential energy at the top is, that means we know what the kinetic energy at the bottom is. The kinetic energy must be equal to 5,880 joules. Okay. So that is our answer right here, 5,880 joules. So that's how you do that problem right there. So guys, whenever y'all see these types of problems on the assignment, be sure you guys understand them, because you guys have to do these calculations on your own. I'm just going through several examples for you all. Okay. But guys, the basic idea, if you understand that the potential energy at the top is equal to the kinetic energy at the bottom, you should be good on all of these problems. And that's exactly what we see here. You know, we clearly see that the potential energy of the skater here at the top of its path is equal to the kinetic energy at the bottom of the path. Okay, so that's the basic idea. You know, potential energy becomes kinetic energy, and in this case, and as it goes back up, kinetic energy becomes potential energy, and that cycle just repeats itself. Again, the total energy stays constant. So if we are ignoring friction, you know, this is just going to keep going on and on and on and on. That situation is going to stay the same. The total energy of the system stays constant if we are ignoring outside forces, which can convert that energy to something else. Okay, guys, we're going to do a few more. I think we have like 4 more to do, 4 or 5 more problems to do, and then I'm gonna let you guys go. Okay. So let me open up a new page. Okay. So this problem right here says a 6 kilogram ball is thrown up into the air with the initial with initial kinetic energy of 75 joules. Approximately how high will the ball rise? Okay, so remember in every last one of these situations here, potential energy at the bottom is equal to kinetic energy. I'm sorry, potential energy at the top. Potential energy at the top is equal to kinetic energy at the bottom. Okay. So, before we can find out the potential energy at the top, we need to know what the kinetic energy at the bottom is. So remember, guys, the equation for kinetic energy I gave you guys last time is 1/2 times mass times velocity squared. Okay, so let's do the math here. So the mass of the ball is 6 kilograms. So remember, 1/2, that's the same thing as 0.5. So I'm going to take 0.5 times my mass, which is 6. Okay. And what is my velocity? Oh, you know what? I'm sorry, guys. That's not the velocity. In my mind, I'm thinking the velocity is 75 joules. That's not the velocity. It turns out they give us the kinetic energy. We don't have to calculate it. Hold on. Let me erase this. I'm doing extra stuff that I don't have to. Okay. So guys, they tell us that the kinetic energy is 75 joules. Okay. So it's important you look at your units so you don't confuse yourself. So the kinetic energy is 75 joules. Okay, so that means by the time this object reaches the top of its path, that potential energy gets converted into kinetic energy. I'm sorry. The kinetic energy gets converted into potential energy, which means the potential energy is 75 joules at the top. Okay. So it says approximately how high will the ball rise? Okay. So guys, this is where we have to use our equation now. If we know our potential energy is equal to 75 joules, and we know the equation for potential energy is mass times gravity times height, we could just plug in 75 here. We could plug in the mass of our ball, which is 6 kilograms. Plug in 9.8, a little g, okay? And then we can solve this equation for height. Okay. Guys, 6 times 9.8, that is equal to 58.8. Okay, now guys, we have one more step here in order to solve this equation for height. Okay. In order to solve this equation for height, we have to divide by h. I'm sorry, we have to divide by 58.8. That goes away. Whatever we do to one side, we have to do to the other. So 75 divided by 58.8. Okay. That gives me a height. So my height here is 1.28 meters when I do the math. Okay. So that's my answer here. My answer here is that the ball rises 1.28 meters. So that is the height here. Okay. So hopefully that makes sense. Let's move on and let's do another one. Okay, guys, the examples that I'm doing now be just like the examples that you're going to see later on whenever you guys are working on your assignment. Okay, so here it says a 55 kilogram object is thrown into the air and it reaches a maximum height of 30 meters. Calculate the kinetic energy of the object the moment it was released. Okay, so remember, guys, in every situation, we're assuming that whatever the potential energy at the top is going to be equal to the kinetic energy at the bottom, and vice versa. Okay, so one form of energy gets converted to the other form. Okay, the total energy stays conserved. Okay. So, okay, so guys, if we take a ball and we throw it upward, okay, we know what its potential energy at the top will be because we're given everything to calculate potential energy. So that's what it enables us to calculate the kinetic energy the moment it was released. Okay, so guys, since we're given everything we needed to solve for potential energy, let's go ahead and do that first. So the equation for potential energy is mass times little g times height. Okay. And so the mass is 55 kilograms. So let's plug in 55 for our mass. Little g is always 9.8. It's the acceleration of gravity. And the height is 30 meters. Height is 30 meters. Okay. Guys, if y'all put that in your calculator, you're going to get a total of 16,000 170 joules. Okay. So that's the potential energy. But the question asks, what is the kinetic energy the moment the object was released? Well, if we know the potential energy at the top, then we know that the kinetic energy at the bottom, must also be equal to 60,170 joules. Okay. So, in other words, when the moment the ball was released, it had 60,170 joules of kinetic energy. And obviously, as the balls went higher and higher, that kinetic energy became potential energy. Okay. Okay, guys, let's do a few more. Okay, right here it says we have a 10 kilogram object striking the ground with 77,500 joules of kinetic energy after falling freely from rest. How far above the ground was the object when it was released? Oh man, hold on. Hold on. Did I skip a problem? Looks like I did. Okay, so here it says we have an 80 kilogram object that is going at 45 meters per second at the bottom of the hill. Calculate the potential energy at the top of the hill. Okay, so in every last one of these situations here, potential energy at the bottom, potential energy at the top. Potential energy at the top will be equal to kinetic energy at the bottom. Okay, so in order to calculate the potential energy at the top of the hill, we need to know the kinetic energy at the bottom of the hill. Now we're giving everything to solve for the kinetic energy. The equation for kinetic energy is 1/2 times mass times velocity squared. Okay. Okay, so remember 1/2 is 0.5. The mass is 80 kilograms. And the velocity is 45 meters per second. That's how fast it's going. So we're going to do 45 squared. Okay. Okay, so guys, if you do the math here, 0.5 times 80 times 45 squared. Okay. So if you do the math here, what you get 81,000 joules of kinetic energy. Okay. So if the kinetic energy is 81,000 joules at the bottom, then that means by the time the object reaches the top of the hill, it would have 81 joules of potential energy. 81,000 joules of potential energy. So that is our answer for this problem here. So here we have, if we know the kinetic energy at the bottom, we easily know the potential energy at the top. So guys, if you want to know which equation to use, you just look at what it's asking for. You look at what it gives you. So here it gives us everything to calculate kinetic energy, but once we calculate kinetic energy, we know what the potential energy is. Okay, guys, let us just do a few more. We're almost done here. Okay, we have a 10 kilogram object that strikes the ground with 7,500 joules of kinetic energy after falling freely from rest. How far above the ground was the object when the object was released? Okay, so remember, basic idea is that the potential energy at the bottom. I'm sorry, why do I keep saying that? The potential bottom, I mean potential energy at the top. The potential energy at the top is equal to the object's kinetic energy at the bottom. Okay. So, okay, guys, we're told that the object has 7,500 joules of kinetic energy. That's what we're told. So, well, so that's how much kinetic energy it had the moment the moment it struck the ground. So if that's how much kinetic energy it had the moment it struck the ground, that means it must have been released with 7,500 joules of potential energy. Okay. So we have everything we need to solve for the height. Because remember, our equation for potential energy is mass times little g times height. Okay. So if our potential energy is 7,500 joules and the mass is 10 kilograms, guys, from there, all you have to do is just do the math and see what you get. So 10 times 9.8, that's 98. So now we got to solve this equation for height here. So we'll divide by 9.8. I'm sorry, divide by 98. That goes away. Whatever we do one side, we have to do to the other. So I'm just left with 7,500 divided by 98. That gives me 76.53 meters for my height. Okay. So what is the answer here? How far above the ground was the object when it was released? How far is the height? Which is 76.53 meters is the height. Okay, hopefully that makes sense. All right, guys, so we're just going to do these last two, and then we're going to be done here. Again, I'm working out as many problems as I can just so that whenever you guys are working on the assignment later on today, you guys will know how to do everything. Okay, so let's look at this one first. This first one says a 3-kilogram object is thrown into the air going 60 meters per second. How high does it go? So here, just like before, we were solving for the object's height. Okay, so again, if you know the basic rule that potential energy at the top is equal to kinetic energy at the bottom, you should be good. Okay. Now, they give us everything to solve for the object's kinetic energy, so we need to solve for that first. Okay, so the equation for kinetic energy is 1/2 times mass times velocity squared. Okay, so 0.5 times the mass. The mass is 3 kilograms. The object's velocity is 60 meters per second, so we're going to plug in 60 squared there. Okay, and we're going to do the math. So when we do the math here, so 0.5 times 3 times 60 squared, okay, that gives me 5,400 joules of kinetic energy. And so guys, if the kinetic energy at the bottom was 5,400 joules, okay, that means the potential energy at the top is also equal to 5,400 joules. So now we could just use our equation for potential energy to solve for the height. Okay, so the potential energy is 5,400 joules. The mass is 3 kilograms. Little g is 9.8. Okay, now we can just solve this equation for height here. So what is 3 times 9.8? 3 times 9.8 gives me 29.4. Okay. I'm going to divide by 29.4 both sides. Okay. And when I do the math there, what I get is 183.7 meters for my height. Okay. So the answer here, how high does it go? It goes a total of 183.7 meters. Okay. Okay, last one. A 3 kilogram mass at rest on the ground is pushed by an 8 Newton force for 4 meters. So it goes a total height of 4 meters. How fast is the mass going afterwards? Okay, so guys, they actually give us a little extra information here that we don't need to know. We're told that it's pushed by 8 Newton force, like the moment it was released, but that's not important. The important thing that we know is we know the 3 kilograms, the mass, and we also know the total height that it goes the moment it was released. In other words, the moment that force was no longer acting on it and it was going upward. So that means we need to find the potential energy at the top first, and then once we find the potential energy at the top, then we know the kinetic energy at the bottom the moment it was released, and then we can use that to solve for the velocity. Okay. So this is the last one we're going to do together. Okay. So in every last one of these situations here, potential energy at the top is equal to whatever the kinetic energy is at the bottom. Okay. So let's calculate the potential energy first, because we have everything we need to solve for that. So the mass is 3 kilograms. Little g is 9.8. Okay. We're told it goes the total height that it goes is 4 meters. Okay. So when we do the math, we do 3 times 9.8 times 4. That gives me a total of 117.6 joules of potential energy. So if the object has potential energy at the top, that means its kinetic energy at the bottom must be 117 joules of kinetic energy. But we're not done because we want to know how fast is the object moving the moment it was released. Okay, so that's where our equation for kinetic energy comes in. Guys, remember the equation for kinetic energy. Kinetic energy is equal to 1/2 times mass times velocity squared. Okay. So with that said, let us go ahead and just plug everything in. So if we know the kinetic energy the moment it was released is 117.6 joules, we can plug everything in. Remember, 1/2 is the same thing as 0.5. The mass of the object is 3 kilograms. All right, guys, we have everything we need to solve this equation here for velocity. That's what we want to know. We want to know how fast it was going the moment it was released. So let's just do the math. 0.5 times 3, that's equal to 1.5. Okay. All right, so everybody understand what I'm doing so far? But let's keep going because remember, we want to get V by itself. Here I want to divide by 1.5. That goes away. Whatever you do one side, I have to do to the other. Okay. So I'm left with 78.4 is equal to V squared. Okay. Now, the last thing I want to do, I want to get V by itself, so that means I need to take the square root. Take the square root of that. Whatever you do one side, I have to do to the other. So the square root of 78.4 is equal to 8.85 meters per second for my velocity. Okay. So that is my final answer. That is how fast the object was going the moment it was released. 8.85 meters per second. Okay. Okay. And that is it. So guys, whenever you're working on your assignment in all of these situations, just assume that potential energy at the top is equal to kinetic energy at the bottom. And of course, depending on the information basically depending on the information that it gives you, that's how you determine what to calculate first. Okay. So hopefully that makes sense. Okay, any questions? All right, guys, give me about 10 or 15 minutes. I'm going to have this video uploaded onto YouTube, and then I'm going to post the assignment for today. Guys, if you all, Pablo, it's not posted already. It is, give me about 10 or 15 minutes. I tell you what, guys, since I won't be available for tutoring today, but I'm going to have a tutoring session on tomorrow from 3:20 to 4. I'm gonna make the assignment due on Tuesday. How does that say on? Okay, so if you get it done sometime before Tuesday, it's going to be on time. If you get it done after Tuesday, it's going to be considered late. Okay, so if you guys have any questions on how to do the assignment, please come to tutoring tomorrow. But basically, everything that I did in the video, every problem that I did in the video will resemble some problem that you're going to see in the assignment. Basically, just follow the steps that I took. Basically, follow the steps that I've taken, and you should be fine. All right, guys. If there are no more questions for me, or if there are no questions at the moment, you guys are free to go. Have a good day.